Find the y-intercept, if any, x-intercepts, if any, vertical asymptotes, if any, including the asymptotic behavior on each side, and holes, if any, for the function f of x equals x squared plus 3x minus 4 divided by x squared minus 2x plus 1. The first thing to do is find the y-intercept. The y-intercept is where the function crosses the y-axis, defined by x equals 0. The corresponding y-coordinate will be found by f of 0, plugging 0 in for the function, which will give 0 squared plus 3 times 0 minus 4 divided by 0 squared minus 2 times 0 plus 1. 0 squared is 0. Positive 3 times 0 is 0 minus 4 divided by 0 squared is 0 minus 2 times 0 is 0 plus 1. 0 plus 0 minus 4 is negative 4. 0 minus 0 plus 1 is 1. Negative 4 over 1 is a negative 4. The x-coordinate was a 0. The corresponding y-coordinate was a negative 4, and there's the y-intercept. The remaining parts are found by taking the function f of x, which equals x squared plus 3x minus 4 divided by x squared minus 2x plus 1, and fully factoring it. The numerator is a trinomial quadratic. It will factor into x and x, two numbers that multiply to be a negative 4 and add to be a positive 3. Sounds like a positive 4 and a negative 1 will take care of that. The denominator is also a trinomial quadratic. It will factor into x and x, two numbers that multiply to be a positive 1 and add to be a negative 2. Negative 1 and negative 1 will take care of that. And now we can cancel any like factors out. The x minus 1 from the numerator will cancel with one of the x minus 1s in the denominator, leaving x plus 4 divided by x minus 1. The x-intercepts, defined by where the function crosses the x-axis, y equals 0, can be found by taking the remaining numerator after factoring and canceling and setting it equal to 0. X plus 4 equals 0, solving for x, it will be a negative 4. So the x-coordinate is negative 4, corresponding y-coordinate is 0. And there is the x-intercept. The vertical asymptotes are found by taking the remaining denominator after factoring and canceling and setting it equal to 0. Solving for x. X equals 1. We can now look at the asymptotic behavior on both sides of the 1, found by taking the left-sided limit of 1, indicated by the negative superscript on the 1, of the fully factored canceled version, x plus 4 over x minus 1, and the right-sided limit indicated by the positive superscript on the 1 of the fully factored and canceled version, x plus 4 over x minus 1. Let's start with the left-sided limit. The left side of 1 means less positive than 1, like 0.99. When plugged in for the x in the denominator in the factor that's making 0, which is x minus 1, 0.99 minus 1 is a negative number. But it will be approaching 0 as x approaches 1, so x minus 1 can be replaced with a negative 0. 1 can then plug in for all remaining x's. So this will be a 1 plus 4 divided by what will be a negative 0. 1 plus 4 is a 5 over a negative 0. The 5 is a positive 5. Positive over negative is negative. Non-zero over 0 is an infinity. The right side limit will work out in a similar fashion, but the right side of 1 means more positive than 1, like 1.01 when plugged in for the x in the factor that's making 0 in the denominator. 1.01 minus 1 is a positive number, but it will approach 0, so we can replace the x minus 1 with a positive 0. The 1 can plug in for all remaining x's, so 1 plus 4 divided by a positive 0. 1 plus 4 is 5 over positive 0. The 5 is a positive. Positive over positive is positive. Non-zero over 0 is an infinity. And there's the asymptotic behavior on each side of the x equals 1 vertical asymptote. The last thing to find are any holes in the graph. These are found by factoring and looking at what factors fully canceled out of the denominator. Now, x minus 1 did cancel from the numerator and denominator, but there was an x minus 1 left over in the denominator. Since it did not fully cancel out all of the factors of x minus 1 in the denominator, then there are none. Holes only occur when the factor cancels all of those in the denominator.